an exciting seminar. To start off, we're going to have Hayden give our opening prayer.
Our loving Heavenly Father, we gather here today at Thy school in thanks for this opportunity to receive this education. We ask that you help us to have a good attitude, help us to pay attention for this hour. This is in the name of Jesus Christ. Amen.
All right, so we have a few announcements this week. Stadium cleanup is this Saturday after the game, probably around 5 o'clock. It's a great way to get out your service points all in one time. If you are planning on going to Rocky Mountain Conference, this is also a very good idea, so you can get some money for your registration fees. We have a field trip coming up on November 15th. This is a really cool opportunity to go to the Olmsted Dam in Provo Canyon. You do need to bring your license, your driver's license, if you are going. And if you are not a U.S. citizen, they ask that you submit your passport before the end of October. They want to do a background check before we go on that field trip. We have a STEM after school program every other week. The next one's going to be the second Wednesday in November. It's a great way to get some service opportunity, to talk with kids about how awesome STEM is. We also have a football watch party coming up. Thomas Schoff and our major, he's number 59 on the team. So that's going to be on November 3rd, probably in the evening. The game time is still to be announced. And don't forget about the faculty versus students volleyball game. This is exciting. November 15th at 6 p.m. in Smithfield House. Remind your professors, say how excited you are to play them in volleyball. It should be blast. And polos. We are getting royal blue polos next week. For those of you who want one, there is a payment link online. It's in the same general area as you would go to pay for your membership fees or any other fees. So go on there and pay for that, and then you can pick it up probably next week. Got adaptive aquatics and Fridays, and then some club meetings. Concord Canoe Thursdays, including today at 6 p.m. Stillbridge Tuesdays and Wednesdays, EERI Thursdays at 6 p.m. All right, here are some networking tips from Forbes. 1, build genuine personal connections. Smile. Listen when you join a conversation and show you are listening. Be yourself and don't try to sell. Research attendees and come prepared with questions. Be a friend, be curious. Bring a friend and be a friend. Be curious. Go in with a strict agenda and try to make a new friend. All right, today we have Ed Rock from WSP Engineers. He graduated in civil engineering from the University of Utah. He worked for UDOT for 12 years and is currently working for WSP, which he's been there since 2006. He is a project manager, a senior project manager and assistant vice president at WSP. He's done some really cool projects, some big projects, including the Mountain View Corridor project here in Utah, and the $1.2 billion Norwalk Bridge replacement in Connecticut. So please help me welcome Ed Rock.
Well, thank you. It's great to see so many of you here and so many of you interested in engineering. It is a great career, and the market is hot right now. We can't find enough people. We're seeing a spike in wages to address supply and demand, and it is never boring. You know, it's a great career. So congratulations, and keep it up. Hang in there. It's tough, but it is worth it. Just first off, who is WSP? Just so you know who I work for, we're a global multidisciplinary consulting engineering firm. We have 550 offices throughout the world. Here in the United States, we generally focus on transportation projects. We do also some vertical buildings work in the United States, but in Utah we are primarily focused on transportation. Which brings me to the topic of my presentation today is, I often get asked what do civil engineers do in the transportation field. I can remember being maybe 17 years old and talking to one of my friends, and one of my friends says, oh, my dad, he works for UDOT, and he puts plans together for roads. And I remember thinking, that is the dumbest job. Are you kidding me? Someone actually has to put plans together for a road? That is ridiculous, right? Little did I know that that is what I would be doing for my career. So, I think there's a lot of misperception about, what exactly do civil engineers do in transportation in general, because it is a big part of our industry. There was an interesting survey that was conducted a number of years ago by the Transportation Research Board, or TRB. They asked first-year engineering students, what do transportation engineers do? What do you think they said?
Count cars.
Majority of them. Yeah, they count cars. They count cars. Did you say that?
Yeah.
That's pretty good. They count cars. That was the answer, right? Well, we do count cars. Some of us. That's one thing that we do, but we do a lot more than that. This is some statistics about what first-year civil engineering students were interested in. Primarily, the majority, 40% of them or so were interested in structures. How many of you in here are kind of a structures emphasis? Okay. So it's a little bit skewed, I think, at BYU because there is a focus on transportation here, which is great, but this generally, as I go and talk to other universities, what I see. And then there was just kind of the rest of the people. A few people were geotech and water, and some transportation, and there were a bunch that were undecided as first-year engineering students. And then they followed through with these engineers and found out where they landed in their careers as graduates. And what they found is generally the structures people ended up in a structures field, right? I was a structures emphasis. I worked structures and a structures job for about 6 months until I saw the light and decided to make the change. But what they found is there were a lot of these engineers who were kind of in the undecided group who ended up in transportation. Any ideas why they ended up in transportation? What do you think? What's that? Exactly. That is where the jobs are. That is where, it's all infrastructure jobs, and that is where a lot of the jobs that will employ you. So many of you, although you may be thinking, I'm not going to work in transportation, I'm a water person or a geotech or a structures, you may end up, there's a high likelihood you will end up in transportation because that is where many of the jobs are. So what do civil engineers in transportation do? Well, certainly as a technical discipline, you can provide support to highway projects, such as you might be a roadway person, you might be geotech, you might be a technical person within a transportation project. But a lot of us, I kind of like to think of a lot of us as architects. You have an architect, the architect hires a bunch of engineers for disciplines, mechanical and electrical. So the architect doesn't really have to know everything about mechanical, but he has to know enough to be able to incorporate it into his building. We're a lot like that with roads, right? So I have to know a little bit about traffic and roadway and geotech and structures and mechanicals. And I'll show you some examples of that, just some of the things based on projects that I've worked on during my career, others in my office have worked on. So again, we're a multi-discipline coordination. Many of us in the transportation world. Some of you may start off in a technical discipline, but over time, as you graduate into more of a project management role, you will end up in this multi-discipline role where you have to bring all elements of engineering together to deliver a transportation project. So just because you're not interested in geotech right now, doesn't mean you shouldn't try to learn as much as you can about it, because if you end up in this career, you will have to know a little bit about it. Certainly we do a lot of roadway and geometrics design. That's a big part of what we do in transportation. There's some people that make that their entire career. And I worked on the Mountain View Corridor, still do work in the Mountain View Corridor. It's 40 miles long. You had to design 21 interchanges, more than 300 alternatives. So we were just spitting out alignments left and right on that project. And as a project manager, I had to know enough about geometrics to be able to understand what the engineers that working for me were doing. This is a photo of the Mountain View Corridor constructed in Utah County. This is Twin Under North. It's being built in phases, so in the future the freeway will go into the middle. It's the frontage road, the outside frontage road. Freeway goes into the center in the future. You'll need to know a little bit about traffic engineering as a civil engineer. This is a photo simulation of a project I'm working on out by Eagle Mountain in Saratoga Springs. And in order to design this future freeway, we had to have our traffic engineers estimate volumes, the number of lanes. So I had to know enough about traffic engineering that I could speak the lingo. And but I'm not a traffic engineer. Okay, and we have to know a lot about bridge design as civil engineers. Again, I started out as a structural person, didn't end up doing that full time for certain reasons, but I have to know a lot. I still do have to know a lot about the bridge design. This is the bridge that we designed on Twin River North in Lehigh over the Jordan River. And this is what it looks like shortly after it was finished. This is a bridge I worked on in Minnesota, in Winona, Minnesota. This is they're putting a second bridge next to this, an existing truss structure. This is a concrete segmental bridge. Don't have very many of these in Utah, but as a civil engineer, I had the opportunity, and not a bridge guy, but I was able to learn about this type of bridge. Worked on another one in Minnesota. That went over the top of an old mine pit. It looks like a lake, but it's just an old abandoned mine area that they mined material out of, and iron. And then it's just filled in with water, because if any of you from Minnesota, or anywhere, there's like water everywhere, right? If you dig a hole, it's going to fill it with water. There's just water everywhere in Minnesota. This is one of the columns that went into the project. It's 200 feet high. It had to be built in segments. They had to cool the concrete because there's such a massive volume of it when they pour these columns, these foundations. But this is the project I'm currently working on in Connecticut, where we're working on a vertical structure over Norwalk River. If I have time, I think I will. I'll spend some time talking about that project, tell you a bit more about that project, because it's a rather interesting project. Something that you don't see in Utah. We don't have a whole lot of vertical bridges in Utah. You will need to know whether you want to or not. You will need to know a little bit about geotechnical engineering as if you have a career in transportation. This is Provo Canyon. This is a project we worked on when I first started at WSP, just some large retaining walls. Here's some, this is a bridge abutment out on Mountain View Corridor that's being constructed. You can see the piles that they've driven there, the H piles, and this is an MSC, a single-stage MSC wall that's building around the abutment. You'll need to know a little bit about materials, right? I have to know a little bit about concrete and asphalt, and when to use each one on a road, and what the properties are, and what goes into a road base. I have to know a little bit about that as our projects are constructed. We have to know actually a lot about transit and rail. It's a big part of our industry. It's becoming bigger and bigger. The project I'm working on in Connecticut is a bridge project, or a transit and rail project. This is the commuter rail line in Lehigh that we helped manage. This is the bridge over Future Mountain Corridor. We helped manage that one. This is the Draper Light Rail Station. Also, we helped as program managers, WSP's program managers on this project, and helped manage the design and oversee the design and construction of all the light rail lines that are in Salt Lake City. We're managing the Provorm BRT that's under construction, or mostly done with that now here in Utah County. And then this is the Norwalk Bridge Replacement Project. I'll get to that in a minute. You'll have to know something about construction management. I actually spend as much of my time, the bulk of my time, either just managing in general or doing construction management. That doesn't mean I'm out in the field most of the time wearing a hard hat and walking around in the dirt, although that's not too bad. Most of my time I spend in office, but most of the time that I spend is managing and overseeing what a contractor is doing on my projects. So you'll need to know about construction management. The more time you can spend in the field to understand how these things are actually built, it benefits you. That's something you should think about as you go into your career. It's very helpful. This is the Mountain View Corridor bridges that we helped oversee the construction of. This is Midas Creek, which is near Burton in Daybreak. And then this is the Norwalk, the bridge over the Norwalk River. This is an existing swing span. So it sits around a pivot, and it's 4 tracks. This is about 1 hour out of, it's in Connecticut, but it's about an hour out of Manhattan. So it's all these commuters, 130,000 commuters a day, board trains that go across 4 tracks here. The problem with this bridge, it was built in 1890 something, and it pivots around the center pier. So when the boats come through, it pivots us boats through. But the problem with it is because it was built in 1890 something, it's at the end of its life, and it on occasion has gotten stuck and won't go back. And when you have 120,000 people that are trying to get into Manhattan, and if you've ever been in New York City, parking is not so easy. Public transit is your friend. It's a problem. Also, when Hurricane Sandy hit, the machinery room for this bridge almost went underwater. And so they got some special funding to have the bridge replaced. They're replacing it with a vertical lift structure. And I'll talk more about that when I get into that presentation. So, but I know a little bit about, for this project, construction sequencing, and so this is generally how they're constructing the bridge. This is a little bit outdated now, but here's the old bridge, and then they bring the barges in, the cranes are on the barges, build the platforms, work platforms, and they start taking apart the old truss adjacent to the swing span, and build the new fixed span bridges at the approaches, and float in the vertical lift bridge on barges. Install the new lift towers, and then in about a 96-hour window, they'll float in the new lifts, one side of the lift span, demolish the old bridge, float it out, float the new span in, install it, and if everything goes as planned, in about 96 hours, trains there will be running back on this new bridge. So, yeah, fun stuff. And out goes the old bridge. You have to know something about tunnels. Not so much if you work in Utah. But as a civil engineer, tunnels are a big part of what we do around the country. And they can be pretty exciting if you get the opportunity to work on a tunnel project. I have to know a little bit of population growth. So anytime in transportation I build a road, I have to understand how many cars it needs to be designed for in the future. And so people, so I need to understand how population is growing. This is a growth chart for Mountain View Corridor. This is the Salt Lake Valley, showing how growth will happen. So if you need to explain to people why you need to install a new freeway, and the number of lanes you need needs to be based on, it just can't be made up. I think we need 3 lanes. You will spend, if you work in transportation, a fair amount of your time interacting with the public. This is our Mountain View Corridor talk track. We put this on this big billboard on a sign on a truck, and drove with these neighborhoods, and then told people, if we would because we had to acquire and demolish about 200 homes to build this project. And so before we did that, during the environmental impact statement phase, we had to go meet with the public. We drove this truck around and then told people, hey, we'll be here for a meeting at 5 o'clock tonight. You can come give us your input. So this is one of those meetings. These are people most of these people are homes, own homes in the corridor that we took. Not a lot of people are always happy when you interact with them, the public, on transportation projects. But one of the fun things is you get to participate in some of the ribbon cuttings and opening events. This is me and my son after the project that ended at 54 South was opened up in December. We had a polar bear fun run, and so we joined the public and celebrated, ran on the road before it was open to traffic. And so you get opportunities to do that. We help staff the event. This is the last project on Mountain View that we opened, that we had a big opening event for. This is the project that was opened from 54 to 41st. We had a 5K, and we coordinated. We worked with the city, and they partnered with us. And the city had it was called an Ugly Sweater 5K, and so some people were or you'll see when you get some close-ups, some examples of ugly sweaters at this event. But it was kind of fun. This is the contractor flew this drone up there, took some footage just, again, before the road was open, so everybody had a chance to kind of run on the road before it was open in the community. So keep your eye out for some ugly sweaters. There's one right in the middle there, kind of gray and orange stripe. Right there, there's some ugly sweaters. But it's fun. It's fun to have that opportunity to interact with the public. And the great thing about transportation is you get to kind of work with citizens and with local governments to plan infrastructure for tomorrow. So one of the things I enjoy most about being an engineer in this industry is knowing that something that I'm working on now, or later, becomes infrastructure, and ideas and things that I talk about or make decisions I make end up, becoming things that people drive on, and bridges that people drive over. So, before I talk a little bit about the Walk Bridge, the Norwalk Bridge, one of the duties that I have with WSP is I hire all of the civils that come, so all the drainage, all the roadway applicants come through me. And I get a lot of kind of frequently asked questions from graduates. So I thought that might be beneficial, particularly to the seniors, but keep in mind, as you're not seniors, kind of keep this in mind. One of the questions I get often is, do I need a master's? Does it differentiate me as a student? So hopefully what I'm going to say doesn't get me banned from coming back to these in the future here. So I'll give you Ed Rock's take on the question is, do I need to get a master's? Okay? I know how much you're all enjoying school, so why not 2 more years of it? So if you're geotech, yes, you need a master's or you're going to have a hard time finding a job. Sorry to give you the bad news or the good news if you like school. Structures, it's not a bad idea. More and more, we are screening applicants in structures based on whether you have a master's. Others, well, it's not as important, but I'll come back to that. Focus on getting your PE. Your PE is key in this business. If you don't get your PE, you will be severely hindered in your career. PE is very important, and as is experience. You might want to consider getting an MBA. I do more business management than I do engineering work, quite frankly. And a lot of the skills you learn in an MBA program would be very valuable as an engineer, particularly because they don't teach any of that to you. And to learn some general business practice would be an excellent idea, even if you're not necessarily doing it as part of an MBA program. Consider working for a firm that will pay you to get an advanced degree. So if there's something you're interested in, and we certainly encourage it, you can work on your degree while at the same time you're gaining experience. Okay, and a lot of companies will pay for it. We pay for it. If you're working on a master's at WSP and you're working for us, we will pay, I think, 75% or 100%. I forget how much. We pay a significant portion of that. So why not get experience at the same time you are getting a degree, working on an advanced degree? So how can you differentiate yourself in the job market? That's a good question. Right? I get a lot of resumes. They all look the same for students. Okay, so how do you differentiate yourself? Well, a couple just generally ideas when you go in for the interview. I know this is going to sound really basic to some of you who know something about that company. You can't believe how many applicants come and talk to me that don't know anything about my company. And most of those people don't get a job. Okay? Now, how do you differentiate yourself? Experience, experience, experience. If you have experience and you have an internship, you will stand out when hiring officials look at your resume as to someone that's just coming out of college. And the good news is I think it's pretty easy to get internships right now. I'm just curious how many of you have done an internship in civil engineering? Very good. Very good. It is a differentiator, and I encourage you to do it. And plus, it gives you an opportunity. The company likes you. I kind of call it the test drive, right? If I like you, and you like me, and we like working together, I'm going to hire you. It's going to be easy. So, But it does set you apart as an entry level versus, even GPA. So, any questions about that before I tell you a little bit about the Norwalk Bridge project? Yes.
So interns, initially set you apart since most people in here have an internship and that's kind of going right now. Can you give more insight into what you prefer in an internship or what is this part in addition to just being the person having an internship?
So I'd say, if you try to find an internship in something that you end up wanting to get a job in. So if you want to be a structures person, but your internship is working for UDOT, that's when you go to a structural firm, that's not going to carry much weight. So that's one thing. Outside of that, you're right. There are a lot of people that have done internships. There's a general variety of interview skills that I've talked about once you get into the interview. Send a thank you note after you interview. You'd be surprised how many people don't do that either. I'd say maybe 1 in 10 people send me a little email saying, hey, thanks. It was a great interview. We'd love to, even if you don't get the job, follow up, say thanks. If anything comes up, give me a call. Things like that. But try to get experience in an area that is related to where you want to work. And find a company to intern for that's going to give you good experience. Okay? If all they're having to do is just shuttle stuff around or do red lines on plans, that's a crappy internship. Right? You get a job that's our interns, I'll tell you right now, our interns for our company, I don't know how many of you drive through the I-15 reconstruction that's going on from the point of the mountain, kind of to the high, how many of you drive through that. We're designing that. Our interns were designing ramps that would be driven on. They were doing geometrics, they were doing horizontal alignments, they were doing quantities, they weren't just doing red lines. So find a company that gives you good experience, so when you go and interview, it's not, what did you do? Well, I did red lines, or I helped do some survey or something like that. Other questions? I don't know if there's classes that you can take here related to that that might help you. That's certainly one way. I mean, I got my experience. I worked for UDOT for 12 years. They have a rotational program at UDOT where they put you through different disciplines. I spent a year and a half in construction, and we'll look a little bit more after that. Just don't become one of these engineers that if your boss isn't letting you go to the job site, try to encourage your boss to, hey, every couple of months, can I just take a tour and drive through and understand how things are done? It's become so easy now with computers and with even with like Google Street View. You don't even have to go out and look at stuff anymore. You can just Street View. Oh yeah, there's a manhole there. I used to have to walk the projects, and so it's easy to just get stuck in an office and never get out there. So as a minimum, try to at least have you work with your boss to get you out there on a regular basis looking at projects. Okay, anything else before I transition here? Let's see. That, okay, so this is a pretty exciting bridge that I get to work on out of Connecticut. It's being delivered using CMGC. Most of you probably have no idea what CMGC is. I'll talk to you about what that acronym stands for. This is the Norwalk, an existing bridge in Norwalk over the Norwalk River. You sometimes might hear me call it the Walk Bridge. Sometimes when people hear me say Walk Bridge, they think it's like a little pedestrian bridge. It's just a short version of what people in Connecticut call it, the Walk Bridge. It's an existing, like I said, swing span for traffic. I've talked about a lot of this. The project requirements are just create this resilient bridge. right now, because it is the swing span, if something goes bad with it and it can't open, all 4 tracks are shut down. So the plan is to replace it with 2 vertical lift spans, work independently, 2 tracks on each. That way, if something happens to this one's still work. This one gets stuck. This one's still working, and they can run trains on it. Okay, so there's that builds some redundancy. Okay. So this was an interesting project. The project started out as we just want to replace that bridge over the river. That's all. Okay. In order to do that, it has to be in half, so that all the trains have to just go to one side. Well, the nearest switch to switch you over on the tracks is several miles downstream, and what that would mean, and the next switch is up. So I think it ended up, I forget exactly, 6 or so miles in between these, so maybe 12 miles, it was a long ways between these switches, and these trains would be in 2 tracks. Now, why does that matter? Because if trains are running on 2 tracks, and the other tracks can't be activated because the bridge is physically gone, if they have a maintenance problem, they got a real issue, right? For 6 miles or 10 miles or whatever it is that they have to work around. So what they said is, well, since you're building a bridge, we need to put more switches in closer to the bridge so that 2-track section is minimized. That's less liability for us as the owner of the railroad. And so we need to add these switches. And then they said, well, since you're there, we have this green Danbury branch that kind of branches off to the north, and it's not electrified. Since your contractor's out there, you might as well do that. And then they said, well, we've got these other bridges, since you're shut down, and they're old and deteriorated, do those too. Build those bridges while you're at it. And since you're out there and the track is closed down, you might as well, for this 3-mile space, you might as well just replace all the track, all the ballast, all the sub-ballast, all the catenary, all the... And so the project grew from a $350 million bridge replacement to a $1.2 billion everything bridge transit project. So the rail work is a part of this, what we call the CP243, the interlocking Danbury branch. There's a picture of it. It's just electrifying the existing line that's out there. They have to run diesel trains now, so they'd like to go with electric trains. This is an Ann Street Bridge, which is being replaced as part of the program. Fender repair. The old fender was rotten, needed to be replaced. The walk bridge, like we talked about, they're raising the whole profile a couple feet, so the approaches leading up the bridge all have to be constructed and brought up. It's super tight in terms of just stuff that's around it. There's an aquarium kind of over on this side. This building right here is about 6 feet away from the tracks from the existing bridge, so working around that is a real challenge out there, particularly when the thing is running 120,000 people a day. People are on it at 4 in the morning, and the last train comes through at Leeds, New York at midnight. Just get out here till like 1:30 in the morning. So very difficult to work on those parameters. Here's some options we looked at. I didn't know, as a Utah guy, I didn't really know anything about these types of bridges. Now I do. The one on the top left is called a Bastial, a rolling Bastial bridge. They looked at that as an option, and 2 different types of vertical lift structures. Some of you are probably from places where you've seen these bridges, these types of bridges. Here's some of the other bridges that are being replaced just because they're in proximity, and the railroad shut down on 2 tracks, so the bridge is being replaced. So the project's being delivered to CMGC. How many of you have heard of CMGC? So it stands for Construction Manager General Contractor. There's 3 ways, generally, that you can hire a contractor in transportation. One is low bid. You put the plans together, everything's in the plans, you put it out to bid, you get bids, the lowest bid wins. Okay? That's low bid. Design build, you don't do anything, you do very little design. You put some basic design out there, a contractor hires their designer, and they do their design, and you select them based on some on qualifications, some on price. But they do the design, okay? CMGC is a little different because you hire the contractor, and you hire the designer during the pre-construction phase. The contractor doesn't have a right to build it, They're just helping you as a construction advisor. Okay, and then at some point they get an opportunity to submit a bid to you, and if the bid is competitive, then you can award. It doesn't have to be low bid, they're the only bidder. They have the opportunity to construct the project. So, again, design, bid, build, traditional low bid. You have a contractor with the designer, one with your contractor. The two don't talk to each other. Agency owns most of the risks, and once the plans go out there, if anything's different from what's in the plans, it's the owner's problem, right? So low bid can be pretty hard. It's worked for a long time. It's still a good way of doing business, but it often can create a lot of friction out in the field, right? If anything goes wrong, it's, hey, it's low bid, so I give it exactly what's in the plans, and so it's different. You got to get used to it. Could be kind of a contentious way of doing business, and not always hiring the best contractor. Sometimes you have the contractor you don't like to work with. Okay, we talked about some deals. The nice thing about CMGC is the owner selects the contractor and based on qualifications. So that means I can hire you as a contractor, and you're the right one to do the work, and I like working with you. That's a lot better than just working with a contractor that I don't like working with. They just got the low bid. Okay. And once the design is complete, they're given the opportunity to provide a bid. Okay. What's good about it? It allows collaboration. It's good to get contractor feedback during the design. They know a lot about how to build things. You get innovations from them. They help you with risk and cost certainty. You know what the price is going to be because they're giving you the price before they give you the final bid. It's really good if you want to optimize cost, schedule, and quality because you work with your contractor during design. This is just a slide that shows kind of risk sharing. So in CMGC, because you're hiring your contractor just as almost like a consultant during pre-construction, you can talk about risks and you can say, okay, what if you guys do this? Well, you do that, Ed, but that's going to cost $5 million because that's pretty risky for us. Well, maybe we don't want to do that. Maybe we should just, maybe we'll hold that risk. And if it happens, then we can find a way to pay you for it rather than just. So it's a good way of talking openly about risk and sharing risk versus some of the other contracting methods. Now, why doesn't everybody use it? It sounds so great, right? Well, everybody doesn't use it because a lot of states don't allow it. A lot of states don't allow it because they require a low bid. They require, because a low bid, you put the job out, multiple people bid on it, you get a low price. Some states feel like they have to be responsible to the public, and that's what matters the most, low price. So it's not allowed in every state. Orange states here on this map. This is a little bit old, allows CMGC. We used it on the walk bridge because we didn't know what the scope was. It's hard to put out a set of plans with the scope of evolving. I talked about they kept adding stuff to the plans. Pretty hard to do that, to put it out to bid, if you don't really know what exactly the scope that they need to construct. We wanted to hire a qualified contractor. This is a complicated bridge. It's a railroad bridge. The railroad's picky about who's doing work for them. It's not your average bridge. It's a vertical. We had to make sure we chose a contractor that was qualified to do the work. That was as important to us as just hiring someone that could low bid it, but maybe wasn't very good at building this type of bridge. So how do you get a price from the contractor if they're not low bid in CMGC? How do you make sure they're giving you a fair price? So we asked them to give us a guaranteed, what we call a guaranteed maximum price. Guaranteed means really only that the scope doesn't change, they're guaranteed to that amount. But they're still able, if they're, if they bid this and something is really different, they still get an opportunity to adjust the price. So they give us a guaranteed maximum price, somewhere around 100%, but not always. Sometimes it can be before that when they give us the guaranteed maximum price is the price. Once the owner and the contractor say, we think we know enough about this job, the plans are defined enough that you can give us a price, and our price, there's enough information in the plans, we feel comfortable giving you a bid, and the owner's the same. Like, yeah, we think that, we're not going to be giving you plans that are so undefined, you're going to have all sorts of risk in the bid. Okay? All right, so the way we validate the contractor's price is typically you have an independent cost estimate or ICE. And they'll do an estimate along with the contractor. And as long as the contractor is within about 10% of the ICE, they're awarded the contract. Okay, so if they're not within 10% of that, so it's not a low bid environment, but they still have to be within 10% of the independent cost estimator. Because we're not just going to say, hey, give us a price, and oh, well, that number sounds okay, 300 million? Sure. No, so we have these ex-contractors who are the ICE, and their job is to make sure that the contractor's price you're submitting is we call it fair and reasonable. Not necessarily low bid, right? Because we're selecting the right contractor.
Question.
Yeah.
Uh,
I was going to ask, even if they're below 10%, so even if it's too low, do you think it's of the contract?
If they're too low, nobody will complain. Yeah. Contractors are pretty good at this, quite frankly, and so we usually don't tell them if they're too low. So we tell them, hey, you're only 85% of the ICE. What's the first thing they're going to do? They're going to raise the price, right? So most owners we'll just tell them whether they're within or without, outside of 10%, not high, not low. They get to kind of try to figure that out. Most of them do a pretty good job, quite frankly. I want to call it game of the system and trying to get close to that 10% as they go along. Other question? Okay, all right. Of course, we can do the estimate comparison. We don't show them the ICE. That would be ridiculous, right? Because they would know exactly what number they had to hit. So the ICE is, we call it blind, or hidden. They can just see whether they're inside or 10, outside of 10%. And we do these estimates as we go along. We don't ask for a price clear at the very end. We'll do these milestones. So we'll do a milestone of 30, and they'll give us a price. And we'll tell them, you're outside of 10%, okay? Then the plans will progress some more. We'll do another estimate. We say, you're still outside of 10%. And we'll do another one, say 90%, right? Give us a price. Yeah, you're within 10%, right? So, and you get to a point where maybe if you're comfortable with their price, you say, let's just go. Let's just award it. Your price is good. So we progressively refine the estimate. This is an example of the estimate comparison that we do out in Connecticut. So again, this is just showing, you can see the contractor's number is kind of bold one after the ones. I think that's their number. And then it just shows whether the column on the right is the ICE. So you can see that they're, on this particular item, for example, track work, they are within 10% of the ICE. This is the third estimate we do. This is not the ICE, it's 96%. Okay. So this is, I talked about doing this progressive estimating, so we estimate as we go along. And these are estimates on our first contract out in the Walk Bridge. We started out around 120 million. The estimators were pretty far apart. After we estimated, we reconciled, figured out what the differences between the estimators, and got a little bit closer than 60%. What happened? Went up, right? And then we reconciled, and then 90% went up again. Reconciled, 100% went up again. This isn't what you really like to see, quite frankly, as an owner. You don't want to find out your job is getting more and more expensive. Any ideas based on what I've talked about today as to why you would see this trend? They just kept adding stuff, right? When we started out with 30%, there was a bunch of track work that they didn't want us to do. They came back with 60%. That's add the track, add the canyon, okay? Which is it's frustrating. This is a curve that frustrates our owner really bad, but part of it is just the fact that the owner is conduct that the railroad operates the railroads. They sort of, it's frustrating because it's not their money, but they have the ability to say, if you're here, you might as well do that. It's hard to argue with them because this stuff is, 100 years old out there and in need of replacement. It's on the East Coast. Everything rusts, right? It's like one of my bosses used to say, even my plastic tools rust out there. So everything rusts, and it's hard to say, hey, we're going to be in there disrupting it. We're just going to have to find the money. But it has definitely been a challenge. This is just a slide that shows kind of how we resolve risk. When we started out, we have what we call a risk register. That's everything that can go wrong on the job. And as we go through these milestones and we try to work with the contractor and say, how can we get rid of that risk? Because if we don't get rid of that risk, it's going to end up being priced into the job. So what can we do to get rid of it? Right? We have some soft soils. And we're worried soft soils are going to be bad for the track, and that we're going to they'll have to do a bunch of remediation. Well, let's do a bunch of testing. Let's do some soils testing to see how much that's a problem. And as we got to the final 100% milestone that was used to actually bid the job, there were only 14 risks left on the register. So CMGC is a great way to be able to talk that through contractor. As an engineer, we can try to figure all this stuff out. But you actually have a contractor who's going to build your job, telling you, what's a commercial risk to them as a builder. You're just kind of guessing. And so it's really, really helpful in the CMGC environment to get that input from them during construction, during pre-construction, not only from a contractor, but from the one that's actually building the job. Because then when they build it, they can't come back to you and say, hey, I didn't know that was going to be a problem. It's like, yes, you sat through design with me for 2 years and we talked about all this stuff. So it's a really good way to kind of mitigate change orders. So that's it, Walk Bridge, Connecticut. It's been a fun job. I worked on how did I get myself into that job? Connecticut's a long ways away. Utah is pretty good at doing a lot of different delivery methods, design build. A lot of DOTs around the country aren't. And so I worked on the first section of Mountain View Corridor, which was CMGC at the time, the biggest CMGC in the country. And when this one went out, they sent an email. I got an email from the company that said, does anybody have CMGC experience? I do. And the next thing you know, I'm in regular trips to Connecticut. So it was a great job. Yeah?
So did you have to have an engineer on your staff who's licensed to do that job?
Yes. Yes, particularly if you're designing, but I don't, obviously, because I don't know how to do any design. I just kind of guide them in the CMGC process and management. I don't do any design. I joke that I haven't actually done anything for years. I just go to meetings and boss people around. I don't know if they like to do anything anymore. Other questions? Yes.
With all the bridges you're working on, say you do, what's the ratio between structural and technical work that you're doing with the bridge?
I'm not sure I totally understand your question, but you mean personally, how much of my time?
You or the company, are you working on the structural work as well as the precision engineering towards the bridge?
It depends on the job, but generally yes. Generally yes. There are some jobs where, because we are a full-service consulting firm, if we're doing the roadway, we're going to do the bridges with it too. It's usually, most jobs, it's about 20%. Around 20% of the design is bridge related. The hours that go into designing. It takes a lot of hours to design a bridge, versus design a roadway. That kind of answer your question? Yeah.
So I know that WSP is pretty widespread, like you have offices in a lot of places, and like you're working in Connecticut, for example. So how do you keep or is there like an office culture at WSP, and like how do you keep that, similar, like have similar values throughout the whole company? Like if you're coming from Utah and working in Connecticut, like is it pretty easy to blend with all the people that you're working with? Like there's a similar value system? Does that
Yes. Yes, they're definitely, every consultant is like that, really. We all kind of have a culture, but we all have systems that are the same system. The same values. We have core values that, goals as a company that we strive for. Just the corporate culture, I'm not really sure how to answer how it transfers, but it definitely does kind of transfer from office to office. And I see cultural differences between consultants. Some consultants are really road warriors that will say, hey, we just go from big job to job, and so people are just always traveling for it. We're more of, hey, maybe we need to find some people that are experts that need to travel, but generally let's let the local office and do the work, and then if we maybe